Welcome to Chapter 3 of Principles of Incident Response and Disaster Recovery, or if you want to call it Module 3. This module is going to go over basically a few strategies. Again, a lot of common sense. Things we're going to cover is the need for your strategies and the archive needs and how you organize your data in order to make that happen. What your alternatives are, and what you would do if you're needing to recover some critical information. Always want to think about that. And once you have perhaps recovered the data, how do you then resume your business process? How do you say you are done resuming? You're done with the recovery and you can now progress. So, the chapter begins with a little scenario where they're doing a little bit of testing. The little scenario here is guy coming in late, splashing his coffee. He's got some white powder going. They rehearsed what happens if they see some white powder. He exhaled, not sure what it was, got everyone out, followed the emergency procedures in the mailroom. Regardless of whether that was flour or dangerous powder, they had to hit the big red button and evacuate. And then an hour later, they're reviewing the response. Sometimes you practice these scenarios. Sometimes they just happen. So, in that scenario, they discuss the reaction and they let them regroup and do an after-action review of how did they do. Could have been a drill, but you treated it as real. So the contingency planning process is what you want to do. Oh, let's go back to that one. CP, remember CP is contingency planning, IR incident response. Contingency planning is all that you do to be prepared for the unexpected. The response is responding to the exact incident. Other phases have to do with functioning of the business. You want to keep the business going as you evaluate how do you have to deal with the disaster. Okay, by the end of this, you'll be able to talk with someone, perhaps in an interview that brings up a scenario. How would you archive recovery the data in order to keep the business going? What you have for choices on archive and recovery, and any changes you may need to make in the business if you're using more cloud computing resources, which has made disaster recovery, I think, a lot smoother. But there's things you have to know about with the cloud. You're much more dependent on your network, right? Because you get to the cloud through your network. And what your strategies are to be resuming business at an alternate, or if you are at the alternate site, how do you get back to the main site? So you've got your hierarchies in your planning. You've got your contingency planning we're starting with. You're going to plan for, think about how the business will be impacted by your procedures. Let me grab my mouse out of here. What are the possibilities in your response? See if my mouse is working. There we go. And then in that response, you have the incident response, disaster recovery, planning with managing the crisis, and keeping the business going. So those are your hierarchies of activities. And often it's separate teams doing that. Okay, we're going to restore your operation. You're not going to be able to do it immediately, so you have some sort of idea of how the recovery can happen and your contingency plan. You may have just a small incident where you have a file accident deleted, or you need to transfer your entire operations over to a new facility. So they bring up 5 mechanisms for continuing your business. The delayed data protection, the real-time data protection, server recovery, application recovery, and site recovery. And I'm going to talk about each one of those in order, I believe, here. So that list is data protection. That's a big part of your security. How are you protecting that? So, backup copies of your data. Now the challenge there is synchronized backup. How old is that backup? How often do you do that backup? That will load your system. That's your critical backup that you have an immediate point in time where you can immediately get back to. In case you have a long term, you need to go recover something that's fairly old. A malware's been on your system for a while. You only discovered it. You realize you had corrupted data for a while. Well, that's your archiving of data, often for government requirements. So having a backup plan, that could be your disaster recovery plan. You get a virus, well, you could spend thousands and thousands of dollars on virus protection, or you say we know we're going to get hit with a virus, we just have a way of backing it up. Now, key is you don't back up the virus into your backup data, or you're recovering the malware, and that's the scary part. So cloud backup is the most popular thing these days, but don't rely only on that. Know how you can do disk backup, and yes, tape backups are still a thing. They're still reasonably cost, and some drives are ridiculously expensive, but you can find tape backup drives that are not horribly expensive. And you have some sort of schedule of how often you're doing that backup, and you have a mechanical way, a very well-known and verified schedule. Do not lose the tapes. That has been it made the news. Someone lost a tape. It conveniently showed up somewhere behind a copier. Maybe someone had stolen it. Maybe they had simply misplaced it. But keep track of how the data is backed up. And that formal policy and plan with lawyers involved, because you may be sued if you didn't show that you were following some sort of standards. As you think of how you're doing your backup, you want to keep first of all, make sure it's not horribly expensive. How long would be down? It'll be more expensive if you need shorter downtime, but if you can live with a half a day, perhaps you can deal with a slower or more cumbersome system, but a lower price. Do you have security? Are you encrypting things? Is it a locked room? Is it secure environmentally? And what's the priority of recovery? Does it fit into your whole planning, or is it just an afterthought? So, based on how well you're doing, how well you know your system, you have systems that are lower priority. Say it's the air conditioner. Okay, we can live with a little problem there. Say it's the archive drive that's gone down. Well, you can live with that, but you better get that replaced. Or you have a spare that's slower. You have the older version. Keep things in the priority based on that risk management. If it's high priority and mission critical, well, you better have some clear plan for that. So based on the priority to your business. And then this takes us back to, well, you better talk about what's the priority. How do you decide what's the priority? So, for cloud backup, um, it's so convenient. One great thing about it is it's handled by a vendor that's well known, that has experience in the area. You're not building your own system in house. And recovery to a different location. You're not carrying physical items. You're getting into the cloud, recovering from somewhere else. Especially when we're talking about websites, you can be cloud-based and have multiple cloud locations. Bring one up as one has a problem or one is being updated. Cloud-based makes things a lot easier, and everyone's moving in that direction. Your benefits of cloud is, of course, faster recovery. You're not getting new equipment in, waiting for an electrician, waiting for someone to move the old equipment out. You're not. It's typically they're in well protected environmentally. You're not dealing with that, and they're well known and have a good track record for their efficiency, flexibility on how you recover. You can decide what platform in the cloud you are recovering to. You could choose a lower cost platform for temporary business because the higher cost, full scale, full speed might be very expensive. You have that flexibility in your recovery platform. And you need know these terms about the cloud, the software as a service, where software packages are being provided for you, applications they call them, in the cloud. With platform as a service, and this is on page 78 in the textbook, you have various platforms available to you, and you basically can use them on demand. Infrastructure gives you multiple systems and network involved with perhaps firewalls as well. Data as a service, you have storage capability, and not just storage for backup, but actually databases involved in that. So data as a service, storage as a service, called cloud storage, have your data in the cloud. And disaster recovery, you could actually contract with someone to actually help you plan your recovery, disaster recovery. And they mentioned in the book several options for the types of services as a service providers. I'd say the most well-known one, the most used, lowest cost, it's been a few years since I've done a comparison, but Amazon Web Services has always come ahead in the amount you get for the cost. I was really disappointed with Azure. It's so hard to figure out where your costs are going to be until you get your first month's bill. And you realize, every SQL server has a cost to it. Every database has an additional cost to it. And you don't realize that until you get your first bill. Amazon Web Service I found a little easier to take and not as many surprises. Haven't tried the Alibaba or the IBM Cloud. Perhaps I'm hoping that in their competition with Amazon, they will bring down their prices too. I have not seen that. And there's different terms for cloud too. You have the public cloud. That's the most common thing you use. Public providers, and have an account with them. In the community cloud, several organizations share computing resources. You can have a private cloud, your privately owned resources. Again, you're paying more for that. And you could have some hybrid of them. Leasing is a security challenge. If you don't own the hardware software, you're trusting them that they are securing their systems. And it's been a while now, but since there were some issues with the election where the company that didn't like particular political viewpoints, they shut down servers based on political viewpoint. To me, that's a major security flaw. Wasn't happy with Amazon Web Services, regardless of the political stance that I would take. What the political climate can affect their support of your services, that seemed like a breach of contract. But That was a big mess. Perhaps the lawyers have stepped in and maybe will make it clearer, but that's unpredictable stability. If and I know if there are illegal activities happening in servers, the law will step in and shut you down. But what's legal or not got a little fuzzy in some ways, with misinformation being made to be illegal. Okay, we'll continue here. So you've got protection available, storing things in disks. Disks are fairly expensive, especially SSDs, but their prices are coming down, so it's becoming more affordable. Disk to disk to tape, or disk to disk to cloud. So you have a backup disk, that backup gets stored to tape, and of course it all depends on your availability, speed of your network, or speed of your tape operations in the recovery. And the security of those things. I would say your own tape kept in your own locked rooms, there's a certain security there. You have control over that. In the cloud, we're trusting that it's going to the cloud encrypted, and you have security with that. But there's a lot of trust in the cloud services with that. Regarding backups, your basic concepts of backup is you are making a full, complete copy of everything you have, and then rather than every 6 hours making a full, complete copy, you say, well, let's not do a full backup. Let's just back up what's changed. The differential backup will be much smaller. What's changed in one day? And then you could do a differential between what's changed between now and the previous full backup, or an incremental backup, which is what's changed since the last backup. I prefer the full backup and then a new differential backup until the differential backup gets large enough, then another full backup. What happens if you do incrementals, when you want to do the restore, you have several backups to go through to get to the final state. And depending on how large those are, that can be a painful and error-prone process. So that's something you would have to prioritize and actually go through the process to know the process and to have a feel for how long you can recover. It is so easy to assume it's going to work, and then you go back and actually do it and you realize you were backing up the wrong thing, or not back, and missing some critical things. I found that out myself doing an automated backup. When I had an update of my system, the automated backup wasn't updated to be backing up the newer version of my website. I came back 6 months later and realized my automated backup was still automatically backing up the old version. And I was so happy that I hadn't had a disaster. But that's something you will be held responsible for if something bad goes on. So, another way of doing a backup is just have a very stable system with redundant disks. There's multiple ways of doing redundancy in your disk drives. Basically, you have hardware or software that's doing the two images to multiple hard drives. The best way to do it is with hardware-based RAID, because if something fails, you replace a disk, and the hardware-based RAID is running again. And most servers, rack-mounted servers, have that capability. I've been using the HPs. They have that. As you're booting it up, you can get into the RAID setting. When you're doing the installation of the operating system, it is not aware that the hardware is RAIDing your drives. That's the best way. You start getting to software-based RAID or firmware and driver-based RAID. When you have a problem, you're having to recover the software to get the RAID to do the rest of it. And just imagine if it's been 5 years, the drivers, you have to go find them or find the new one for the current new hardware, and it can be a nightmare. But you can make it work. But I highly recommend use the hardware-based RAID. Lots of different RAID levels. Don't worry about memorizing all of them. Generally, the mirroring is generally better, but it's more expensive. Striping, you get more out of your hardware, but you're a little more at risk than with mirroring. But multiple levels. I like the RAID 5 myself because, and the hardware has that availability where I can have basically duplicate copies with parity, meaning I can recover files that are corrupted. And typically, they don't mention that here, in the HP servers, there is a automatically spare drive kick in. So you can have a drive fail, the spare drive kicks in automatically, and you have an orange light on the drive that failed. You simply go back and replace it. It gets re-imaged automatically through the hardware, and your spare becomes a spare again. So I love RAID level 5, but I think it's not quite as fast as a RAID, some will call it 10 or RAID 1+0. So just visually kind of a picture of how RAID works, where here you have RAID 1 where you're using multiple sets of disks. RAID 0 is really not redundant. You're just spreading data across multiple disks. If one disk fails, your disk has failed. With mirroring, you can lose a drive and you can still recover your data. So RAID 0 is like, hey, I'm running out of space. Let's stripe in another drive and extend it across multiple drives. RAID 1, you can add drives. It's a little more involved. RAID 1+0, you're striping and mirroring that striped set of drives. Striped with parity, you're using multiple drives, and you have a hot spare that automatically kicks in, which is not displayed here. I like that the best. When you're using databases, now we're not talking about, the drives haven't been corrupted, but databases can be corrupted with bugs in software typically. And so with your databases, not only do you want them stored on rated drives, but recover some to the original state if someone made a bad operation on the database. And so you're doing locking any operations on the database while you're making a copy of it, or the lock and copy, you have backups in the cloud. Continuous synchronized backup. Think of a database not residing on a drive, but you're making a continuous backup of the state of the database. Applications themselves, sometimes they take a lot of configuring when installing applications, so it's nice to actually, once you have an application installed, have a backup of that program files folder or even the system settings if you're running it. And that's where the virtual machines come in. You can have an application being served on a particular virtual machine, have a snapshot of that machine. If the application fails, well, you just recover the application server and you're back in business. Of course, the application server may have some data that will deal with the actual backup of the configuration or the data that the application is serving. So you want to have applications backed up as well. So the whole backup plan, when does it happen, how long do you do it, and do you periodically test it? That's the part that no one wants to do. That's the mundane, you're spending money, not gaining any customers, just testing that your backup works. There are companies that they will actually have, especially in manufacturing. I worked in 3M manufacturing, a company that did manufacturing. They had a month where the factory people would come up to see could they make the product in a completely different place. Very expensive backup test of their backup capabilities. They're now iMation, that particular plant that I worked with. Okay, what is the long-term storage or document? Typically, I would say that's the archive. Yeah, your archive is your long-term storage. And Amazon Web Services does offer a glacial storage, which is slow but archival storage. Lowest price storage for them. Might even be taped as far as we know. Another nice thing about the cloud, we don't care what format they stored in. We just care what the price they charge per terabyte. So, if we're recovering and want real-time recovery, well, Uh, you've got a variety of options here. Real-time protection using RAIDs, as they have these terms: hot, warm, and cold servers. Bare metal recovery, you can replace your entire system if it would fail. Of course, you better use a standard kind of system, like a particular type of server that's common and not 20 years old, the only one left in the world. You can recover to a system if it's reasonably compatible. You can do multiple servers in a clustering type arrangement. It takes a little more sophistication in how it's organized, but you could recover to a system where there's, think of it, a little community of servers providing your application support. Transferring data on and off site using electronic vaulting. Transactions, this typically run into this when you're talking about databases. You're journaling what's being done since the start of the operations on the database. But this can also be done, and typically I've seen it done in the file system. It's a journaling file system. It keeps track of what operations have happened. Think of that as like a separate record of what's been done to a disk drive. Offers some backup stability. Shadowing, think of that as a mirror, but you're keeping a copy of it in a remote location through a VPN, if you like. And you can snapshot your data from one to another. Or suppose you have two databases serving customers. Well, you've somehow got to merge the data from multiple databases into hey, here's the result of all our operations. Or you could keep track of what transactions occurred and periodically copy what was done. All of these things are something that would be transparent to the operators. Sys administrators would know what configuration they have. And you can have storage kept in network attached storage or systems that have high quality storage. Basically think of it as storage over the network. You either have servers or that share a high network between them, or you have a high-speed network shared with your server. So here's your network attached storage, where multiple servers connect to a RAID array, or you have a storage area network where you have special channels between storage units connected to the server. Typically this is more expensive but faster. And for you, just recognize the term is, well, storage on the network, one is more expensive than another. And then when we talk about security, think about, well, there's one way in to the storage, where here there may be multiple points have access to the storage. My general impression is this might have more of a security challenge for credentials getting at the data. And that comes in, and also the overall cost of the system. You have to keep that in mind. So there, let's see if what I just said matches what they have on their table. That in the connectivity, any machine can connect to your over the LAN to your storage, where on the storage area network, only the servers can connect to the data. File transfer is through specific protocol here, file name with the network storage handling the security. Here, no individual security control, simply by block number. But remember, that's only accessible from your servers. Network attached is more compatibility with operating systems. This is more operating system dependent, may not be compatible. So the machine providing the storage area network is probably only compatible with the same operating system machines. File system is managed by the network attached storage, what they call the head unit. Here managed by servers. Backups save time and bandwidth because they're going over your network attached storage. Here, they're done in blocks, requires higher capacity, more I'd call it looks like more dedicated storage devices. Now, virtualization is a big part of the world today. Hoping you're familiar with this. Basically, deploying your machines in a server that pretends to be the hardware, emulates the hardware, and those are virtual machines. The host is the server running the multiple virtual machines inside of it. So that's your host platform. The guest machines are your machines running inside the host. So VirtualBox is the virtualization host platform. VMs can be created inside VirtualBox, or Hyper-V, or VMware. Those are the three most popular host platforms. The one hosting all the VMs is called your hypervisor. Some call it the virtual machine monitor. I come across hypervisor more often. It can be hardware-based or operating system level virtualization. Application level virtualization, I see that called containers or Docker. That will be your application level virtualization. And you can choose any of these variations. You just have to understand how they work. You're virtualizing a whole operating system, or you're virtualizing an application. Back at other devices that need, and of course, with all that virtualization, you can be backing those babies up. And other devices, tablets, phones, data storage, depending on how they're being used in your business, you better have some mechanism, some procedure for backing those devices up if they are at all critical to your system. Back up your, I've been doing that myself. I have a password manager. Man, if I lost those passwords, I'd be in trouble. I regularly keep a backup of my backup passwords, but I better encrypt that file. Backup of your devices that are critical to your system. Do you have redundancy built into your hardware that just is your networking equipment? Typically what I'll do is when I buy new networking equipment, the old stuff becomes my backup. I don't take it out of the system unless I don't have any room in the racks, but they become my backup. If you can afford it, when you buy a network, you have redundancy built into your networking. That doesn't necessarily mean you have two of everything, but you have alternate paths through your network. In case one network room went down, could the rest of the company still communicate to each other? Or are you in the daisy chain and the chain is broken? As you plan for your site recovery, well, you've got to have some procedures how to get back in business as soon as possible. Do you know if you say you had a fire at your site, do you have an alternate site where you could keep business going? If you have a site that's ready to go, that's a hot site. If you have a site that's mostly ready to go, but you have to do some configuration, that's a warm site. Cold site is, well, they'll have it available when you need it. It might take longer. You can have money sharing a timeshare system, have some contract with a server bureau, or you share some kind of agreement with departments in your company or with a sister company or a partner company that you can use their equipment while you're recovering if you are trusting each other. And you could contract with a mobile site producer. They come in with a truck with all the equipment that you need and plug it in and connect it through your network, and they are your mobile hot site. Hot site fully configured. A mirrored hot site means it's actually could be immediately switched over to be your primary site. If you're a big business and you're highly dependent on staying live, this is what you'd have. You'd basically think of it as a cluster where you could pull out part of your cluster of servers and still have your site active. Warm site, same services, some things not completely configured. Cold site, basic services, no computer peripherals provided. You bring them in, you order them, you get them running when you need it, but there's perhaps a building ready to connect. So look at the costs. Of course, a cold site would be low costs. Kicks in the cost when you need it. High, mirrored, and hot. If you organize your servers, here is your a hot site ready to bring up, perhaps a rack dedicated to your company out there in the little server farm that they have. You're paying for that just to be ready to run when you need it. And if it's hot, it's running and actually getting mirrored data and acting as your backup that's basically hot, ready to go when you need it. Here's your cold site. No equipment there, but plugs ready to go, perhaps network wiring ready to go. You move your rack or you order the rack and get it going ASAP. It's going to be coming up a little slower, but it's lower cost. Timeshare, like a hot site, but you lease it with your partner or your parent or sister organization. Some agencies, businesses will provide this for you, or you have some kind of agreement. Mobile sites, they can bring the material and bring the hardware to you. Storing resources externally, well, that feels a lot like a warm or hot site. Service agreements is dealing with the promises and security if you're organizing a hot or cold site. There's issues when you're sharing it with someone else. Do they promise a certain level of bandwidth, certain response time when you need them? And if they don't provide that, you have an agreed upon lower cost, or you sue them. Any kind of agreement should be clear on what's being provided, how it's going to be done, how you're going to verify that it's giving what you need, such as, is it providing a certain bandwidth when we hook up? Do we have that recovery time that they said you'd have? How are we going to calculate those measurements, and how are we going to be charged for it? What happens if they fail to deliver? Do we get the refund, or do we have to sue them? And as things change, do we see costs go down or up over time as data prices go up or down? Who's responsible for what? What fees will be paid? Who's going to admit responsibility? And they're not going to be competing with your business. How long does that agreement last? Cost structure, priorities, and as changes are made, who's responsible and how does that happen? Lots of other issues. Security, this could be a long document, how you're handling access to the information. Testing it, how much room you have, are people going to need to be there? Do you have an environment for workers to be able to work at the hot site? What kind of supplies, costs, power, or wiring? Or is the wiring all ready to go? To bring in a spool of 1,000-foot network cable to get things hooked up? Any other requirements? Is it environmentally safe? What if there's a fire? Who's responsible for putting out the fire or paying for who left the door open if somebody got in and messed with the system? So what is the fully configured computer facility, all services capable of established operations at a moment's notice? That definitely would be your hot site. Okay, so summary of this. You've got your contingency planning, CP, your business resumption, business recovery planning, your data recovery, disaster recovery plan, business continuity plan. Those can be separate teams or all part of the contingency planning. Remember, your mechanisms for restoring are delayed protection, real-time protection, server recovery, application recovery, and complete site recovery. Cloud has made a lot of things easier. You need to understand how the cloud works and how what your options are there. Make sure you have your backup plan. Are you using RAID in your configuration? Is it built-in backup? This is something that should be in every server, as well as backup of what's being stored on those RAIDed devices. Have recovery plans, cold site, warm sites, your options there. And there we have it. A quick review of your disaster recovery plan. Hope you enjoyed it. Hopefully just reviewing this, listening through this will help you remember the material. And you have a wonderful day. I'll go back up to slide number 1 here. 1, enter. And that's it.